Thank you everyone for attending our session today on reinforcement fine-tuning. As a brief introduction, I'm Dev, one of the founders and CEO for Predibase. I'm joined today with a few of the core engineers on our team who I'll let introduce themselves right now and are going to be speaking towards different parts of our reinforcement fine-tuning product that we've built over the past few months. Samir, would you want to introduce yourself?
Yeah, definitely, Dev. Hi, everyone. I'm Samir. I'm a research engineer at Predibase working on some of the core fine-tuning technology innovations we're doing.
Excellent. Jeff Tang, perhaps you next.
Hi, I'm Jeff. I'm a software engineer here at Predibase, working mostly on the platform and orchestration behind the scenes to enable things like RFT.
And then Jeff Knissen, take us home.
And hi, I'm also Jeff. I work on the ML experience team, mostly on fine-tuning, scalability, and performance.
Awesome. Our entire team is really excited to be able to share more about what we've been building and really introduce us towards the newest functionality in the Predibase platform around reinforcement fine-tuning, which we think is going to drive a lot of the future of LLM customization. As a quick note on webinar logistics, just off the top, all lines are muted by default other than those of the speakers. If there is anything that you would like to be able to share, we absolutely encourage folks to be active in the chat, which looks like it's already gotten started. Today's session is recorded and will be made available to anyone who's registered afterwards and will also be posted online. If you could please take a moment to participate in the poll that was just shared, it really helps us understand both the audience that has joined as well as how we can make sure to tailor content. So if you're able to take these next 10, 15 seconds or so to be able to participate in the poll, that would be very useful. We have a lot of content that we're going to get through today. And so in case we have time, we'd love to be able to save it at the end for Q&A. You can submit your questions in the panel for a live Q&A that we'll look to be able to do about in the last 10 minutes of the session here today. And then lastly, you can visit our website to get started with any of the technology that we're actually going to be demonstrating, as well as get access to some amount of free credits that makes it very easy for you to be able to start to train your first model, serve and deploy it as well without having to break the bank. Today, I'm actually really excited to be able to dive a lot deeper into what we're doing with reinforcement fine-tuning. And this is a large bet that our company made, really based on what we've seen evolve in the industry and where we think both frontier and open source models are really going. So I wanted to start off by talking a little bit about why we're excited about reinforcement fine-tuning, when to use RFT, and how it compares against SFT, the types of use cases that we've seen customers be the most successful on using it so far, and then really get into the nuts and bolts of how it works, defining what's a reward function, walking through some empirical benchmarks that we've seen on those, and then give a live demo of what GRPO and managed RFT looks like exactly in the platform. So with that, I wanted to actually just touch a little bit about personally why I've been so excited about reinforcement fine-tuning. I've worked in the machine learning space for over a decade now, and our company has always been oriented on how do we democratize access to deep learning and training and fine-tuning of large language models. Through that time, we've kind of realized that yes, 90% of machine learning is really about labeling data, and the other 10% tends to be about complaining about labeling data. In order to get the best possible performance out of models, we have noticed that fine-tuning is a consistent way to be able to increase the quality of your models while also being able to optimize for speed, like throughput, or the cost of the model by having a smaller model do what a larger model was doing before. And we worked with a number of customers that we've talked about previously, like Conversa, Upstage, and Checker, and many others, to be able to demonstrate that quality actually improves dramatically once you're able to fine-tune on your own data. The biggest issue that I think we've run into with a subset of our customers, though, is that all of these efforts have conventionally required manually labeled or distillation data sets that were collected, again, manually over from larger models. And this presents a challenge, I think, to getting started with fine-tuning, because it means that you need to be able to actually create data sets, oftentimes hundreds or thousands of examples, before you can actually get started and see some of the value that we actually unlock for a lot of the organizations that are doing this in the future. And this, I think, is really where we have been excited to take the bet on RFT, and where we think that it is going to help a lot with organizations and the types of value propositions they need. We find three types of settings in which it makes sense to use reinforcement fine-tuning. The first is that when you have no labeled data, but you can verify the correctness of the output. So another way of being able to say this is you don't have structured labeled data and thousands of examples of what good or bad was, but if the model came up with an answer, you have a very structured way of being able to score that answer and know if it's good or not. The second that we see is when you have limited labeled data, not enough for supervised fine-tuning, but maybe dozens of examples that you can use as part of the verification process. And then the final condition or property that we often find indicates that reinforcement fine-tuning might be useful for your problem is that if chain of thought improves the overall model performance. Or put another way, if one of the larger reasoning models is particularly adept at the task that you're looking to do, then we generally find that reinforcement fine-tuning can work well on that as well. We've published a flowchart that also helps you understand what are the kinds of areas or settings in which you can think about the different types of model customization techniques. Everything from RLHF, reinforcement learning through human feedback, to RFT or supervised fine-tuning. In general, we try and break it down into two types of questions. The first is, how much ground truth or labeled data do you have? If you have less, then you want to use one of the more reinforcement learning oriented mechanisms. And if you have more, you want to use one of the more supervised fine-tuning oriented mechanisms. And then from there, if the task is verifiable or not. The way that we think about verifiable is, can you write a scoring function, a rubric that allows you to actually be able to tell whether this works well, or what we oftentimes call in our product reward functions. We're going to dive a lot more into that in just a few minutes. One of the things that people ask about after we talk about general properties of where RFT makes sense is, what are the kinds of use cases that we see success in? And the first thing I want to indicate is that I think that the overall industry is quite early when it comes towards reinforcement fine-tuning. So I think we're going to learn a lot more about the use cases that are going to be popular in the coming months. But so far, we've seen a lot of success in three types of use cases, both I think that are highly verifiable. The first is in mathematical problem solving, models that want to show their work, provide detailed reasoning, come up with formulas. The second is in code generation, debugging. We work with a lot of organizations today that want to generate their own domain-specific language or customize models to be able to generate code that really matches their internal schemas and want to understand the structure and intent of the code. And then finally, we see these models work really well for logical and multi-step reasoning. Ones that where you might want to explain the step-by-step logic, or are really looking to be doing a lot more complex RAG. When we released reinforcement fine-tuning a couple of weeks ago, we also released an open source model that we had built to convert PyTorch to Triton code that we saw far outperformed any of the other models like DeepSeek R1 or O1 on the kernel bench benchmark. This was a model that we trained using Qwen Coder 32B Instruct, and we noticed significant performance gains with just a few weeks of kind of training through the RFT process. And so we've seen this be really promising on use cases and domain adaptation in code, and are now actively working on organizations on many different application areas that they have with reinforcement fine-tuning. A lot of the motivation for RFT really came from the DeepSeek R1 launch, which I think put open source models ahead of even frontier models when it came towards reasoning tasks. And while there have been many narratives about what made DeepSeek so compelling, to me, the most interesting thing that really came out of the launch was the novel algorithm that they had developed around GRPO, which we've extended to improve. But the novel algorithm that they came out with GRPO that allows organizations to not only do things in a more compute efficient way, but a data and sample efficient way as well. And so we're going to be talking a little bit more about how this algorithm gets applied for any of the types of use cases that you've seen above. And towards the second half of the presentation, we're also going to be showing you a little bit of what it looks like to build a full end-to-end managed platform that actually executes on the reinforcement fine-tuning vision, and why certain aspects of it require tight integration between a training stack that is able to do fine-tuning and a serving stack that is able to dynamically load in every latest checkpoint that you're using reinforcement fine-tuning with and score those with each model iteratively. So we're going to go into a lot more detail from here. I wanted to provide a bit of an introduction and also motivation for why we are so excited about reinforcement fine-tuning. And what I'm going to do next is hand it over to Samir to talk about a little bit about just defining reward functions, what you heard me kind of describe as rubrics before, which are really the fundamental building blocks for being able to do reinforcement learning well. And Samir is going to walk through both what reward functions are, as well as a sample use case where they can be very helpful. So Samir, I'll go ahead and hand it over to you.
Thanks for that intro, Dev. So I'm going to talk a bit first about reward functions now that we've got an idea of what RFT is like and understand a bit more about how you can start building solutions for your use cases. So reward function is ultimately just something that's going to score your model outputs. And you're going to want to give a score greater than 0 for positive feedback and 1 less than or equal to 0 for negative feedback. And it can be really any metric that guides the model towards desired behavior or outputs. So for example, like if you had a SQL task, you could check if a query compiled, and if it didn't, you would give some negative feedback. Or the example here is just checking that the output is adhering to a correct format in terms of the tags requested in a prompt. So the reason to use reward functions is they're, at a high level, they're way more flexible than the typical training process with LLMs, where you have to curate essentially a set of tokens that are labels for what your model should output. With reward functions, you can get flexible and dynamic feedback. You can score outputs based on the behavior, and you can enforce structure with these format type rewards. You can also add additional constraints, like for example, these reasoning models tend to use a lot of tokens. You can add reward functions that penalize longer outputs, and the model can balance correctness and efficiency at the same time. And you can focus on the eventual outcome, which is key for long horizon agentic tasks where the model might be reasoning, it might be using tools, might be doing all sorts of stuff in the process to get to the end outcome. And you don't really have the ability to go label a bunch of trajectories and plans on how exactly to do each of these things, especially with more complex problems. So you can imagine use cases like search, how difficult it would be to curate like an exact SFT data set for something like that. So the key outcomes of using reward functions in RFT is that you can get better results with less data. And the core thing that enables this property is that the model is able to explore the space of outputs much more than an SFT while trying to optimize the reward. And so typically we see orders of magnitude less data getting better results. You can build in reasoning where you can let the model think for as long as it wants before responding. And this tends to improve performance across the board. And there's not an easy way to do that with SFT. And something unique about Predibase that we offer is live updates of your reward functions, which can change your training trajectory as it's going on. And this can allow you to add additional constraints to your problem or tweak your reward functions as you see the model doing reward hacking or you see issues in how you define the reward in the first place. So one of the most well-known use cases, right, is RFT to verifiable tasks like mathematical reasoning. So like the DeepSeek R1 paper. And these ones, the reward function is very simple. You're just basically checking if the answer matches exactly some ground truth solution. But there's a lot of really interesting use cases that are still just being developed now where RFT is poised to completely change how we're able to solve these problems. So one example is code generation, which really excites me as a developer because, we've all learned about test-driven development. And now with RFT, you can write the tests and have a simple reward, like on the right here, where you get a +1 if the test pass, -1 if the tests fail. And just let the model do its thing and you'll end up with code that might meet your task. And all you're blocked by is how well written your tests are. Another really exciting use case is with more open-ended outputs. Like we saw the mathematical reasoning case where a ground truth answer, but in real life situations, we often know the ground truth answer, but in something like summarization, there's a lot of ways to write a summary. So something like a simple, string matching objective will not give you the reward that you want. It will not grade similar outputs correctly. And here you can still use even another model to grade your outputs as your reward function. And this opens up the opportunity to using LLMs not just for generation, but also for verification and feedback. And another use case, which, if you want to think of some examples, think of like some of the stuff OpenAI has been doing with operator, computer use. So a lot of agentic tasks where it's actually very easy to verify what you want the outcome to be and whether or not it was done. So one example I like is, imagine I asked my LLM system to buy me a concert ticket for Krungbin for this Saturday night. Now, it's really easy to check if this actually happened. I can go check if I got an email verification or hit an API for Ticketmaster to see if the ticket was bought. Very easy to check in a programmatic way, but very difficult to generate. You can imagine the model will need access to a browser, access to use clicking on things. It needs to do a lot of reasoning, planning. So this is an example where SFT has really not been able to succeed at all, but RFT is extremely promising and ripe for making this possible. So now I'm going to dive into a real world use case where we applied our RFT platform to get significantly better performance than much stronger models with a very small number of labeled examples. So the task we're talking about today is function calling, which is, a core agentic skill. And the core skill that we're going to evaluate the model on is simply whether it can select the correct tool or not. And, why function calling is important is, imagine my user had a workflow where they wanted to plan a trip and they gave it tools like creating calendar events, looking up flight prices, or sending emails, all part of the organizational planning. Now, for the LLM to do this task completely correctly, not only does it have to use these tools correctly, but the use of tools and planning all depend on each other. And so any failure in any step of this chain can cascade down the chain and ultimately lead to an unsuccessful result for the user. And so in use cases like this, we want the model's accuracy to be 95%, 100%, 80%, 85% is not good enough, because even just adding 2-3 steps to that plan reduces the end-to-end accuracy significantly. So the data set we're going to be looking at is this Glaive function calling data set, where essentially the LLM is given access to a set of tools in the system prompt. So in this case, we have a tool that is used to create a calendar event. And one important aspect to remember is that these tools also have required arguments and sometimes optional arguments. And so if you're going to use the tool, you have to supply the required arguments. And the user here asks to create a calendar event. And what we want the assistant to reply with is it can reason for as much as it wants between these think tags, and then has to output these tool tags and output exactly the inputs for the function, which is the function name and the arguments. And in this example, we only have one tool, but this data set can have one to 5 tools in each example. But the user message will only ask the assistant to use one tool at a time. So it's simpler than a lot of even more ambitious use cases, but it's surprisingly hard even for state-of-the-art models. So I'm going to first look at some of the common mistakes that even quote unquote more intelligent models make with this task. So one common issue is that the model will call a tool even when it has insufficient information. And so using the create event example, this message is an actual message from the data set, which is the user says, I want to create an event in my calendar. Now, the model should not use the tool at all. It should output the tool tags with no tool use within it, because it doesn't have any idea what the event title, start time, or end time should be, right? And you can see here a reply from Quen 32 billion. And it correctly even reasons that it doesn't have the required information to fully use the tool, but it still goes and outputs the tool with these empty arguments, right? And even with prompt engineering, these mistakes still pop up. Now, Another example of this with GPT-4o, and an example I consider more insidious, is we have this tool called check word count. The user asks, I have a text and I need to know how many words it contains. Can you help me with that? Now, clearly, the user has not provided the text yet. And so we don't want the model to use the tool quite yet. It needs to wait for additional input. But GPT-4o goes ahead and tries to use the tool, and it passes in this placeholder text. And this is even more harmful because you can imagine if you have a automated backend workflow using these responses in a chain, that you might actually go call check word count. You'll get a word count of 1, and then you'll basically be replying to the user with a nonsensical answer. And that can be very, very frustrating to users who expect much more intelligence from these models, especially in this routine sort of decision making that is a real bit important subscale in agentic workflows. So some other common mistakes are just like formatting mistakes, and one issue with these formatting mistakes is they happen infrequently, but enough to be irritating. 1 in 10, 1 in 20 results. So in the first one, the model outputs not just the dictionary we want, but this tool call keyword behind it, which will mean when we go try to automatically parse it in the back end, we're going to hit some errors. And the bottom one, you can see this more complex tool call, more complex schema. The model adds an extra right brace. So this again will not compile. And the only real solutions to handle this problem currently are either, prompt engineering, which tends to be a bit of a game of whack-a-mole, or some sort of structure generation library, which adds a bunch of complexity and even has been shown to affect model performance and accuracy downstream. Right. So with RFT, we're hoping that we can tackle all these problems by simply defining some really simple reward functions over a small number of labeled examples. And that's exactly what we're going to do. So the 2 reward functions we're going to define, one on correctness and one on format. So the format function, right, is just going to check the structure of the output. So does it have correctly open and closing thing tags? And we give partial credit for partially correct responses, and this really helps the model knows when it's heading in the right direction. And then we check if the tags are in the right order, so reasoning and then the tool output. Then we check there's only one set of each tags, so that the model, because one of the constraints we defined in the prompt for this problem is to only use one tool at a time. And then finally, we want to check if the actual tool call, if there is one, is parsable as like a dictionary and it contains a name field and an arguments field. For correctness, we have 2 possibilities. If the ground truth does not use a tool at all, then we'll get full credit if the model also chooses to use no tool. If the ground truth does use a tool, we first check if they both use a tool, we give a partial reward of 0.2. And then we give an additional reward of 0.4 for a total of 0.6 if the names match. And we finally bring that up to the full reward of 1 if the arguments also match. So really, it's that simple, right? And for the RFT training, there's only 20 labeled examples taken randomly from the initial data set. And the results are striking. So here we evaluated on 150 holdout validation samples. So starting from the left, right, the Quen 32 billion model, which is an order of magnitude larger than the model we trained with RFT, which is the 3 billion size model, gets 83% correctness score with the exact same correctness function I defined here, right? And GPT-4o gets a similar score of 0.81. Now, surprisingly, even after adding the 20 same training examples as few shot examples in the prompt, GPT-4o does not improve. Upon investigating the results, it tend to make the same mistakes as before, calling tools when it didn't need to, despite examples showing exactly use cases to not do this. Now, meanwhile, the 3 billion Quen model, right, out of the box, it gets a score of 0.6. And we would really love to use this model for this task because it's so much smaller and faster, and we can use it as part of a larger system and can really help reduce latency. So we might first check out SFT. And SFT, 20 examples gives you a great boost of 10%, but it quickly saturates. Even up to 2,000 examples, we just about get close to the larger models. And it's unclear how much more data will we need to even get to that 90%, 100% accuracy we really want. But with RFT, with the 3 billion base model and only 20 labeled examples, we get a 99% correctness. And actually even training the model to get to that correctness only took about like an hour. So it's clearly not too difficult of a task for it, but RFT is the right tool for the job to actually get your model to perform. So with that, I'm going to now hand it off to Jeff K to go through a live demo of how GRPO looks on our system.
Thanks, Samir. So for the next 10 minutes or so, I'm going to be walking you through how to run the function calling example Samir just walked us through in Predifine. So I've set up this notebook here where we're going to set up our data set, our reward functions, and then start a training job in the SDK. And then we're going to flip over to the app and take a look at the observability tools we built to help you understand how your training jobs are working. So first off, we're going to install the Predibase SDK. I've already gone ahead and done that just to save some time. Next up, we're going to load our Glaive function calling dataset. This is the same data that Samir was just walking us through. And we're just going to take a look at this real quick when it downloads. So here we have just a few rows from the data set. When you're training with RFT in Predifine, the only requirement for your data is that each example has a prompt field that contains the prompt you're going to run through the model during training. You can also include optional additional columns fields like this one, the tool call, which we're going to use later on as a sort of ground truth to check the model output and generate our rewards. So if we, just as an example, if we look at one of the prompts, so we're giving it the task of, your task is only to select the correct tool, given a user message and a list of possible tools that you can use. You should use at most one tool per response. We're also directing the model to place its reasoning inside of a pair of think tags and to place its response, its answer, inside of a pair of tool tags. And so for this example, the user message is, can you tell me the current stock price of Apple? And we tell the model that it has access to a tool called get stock price. And we would expect in the output to see the model select the get stock price tool and give it the argument AAPL for Apple's symbol. From here, you can write if you haven't already uploaded the dataset to Predibase, you can write the dataset to file, and then later on I'll show you how to get it into our system. Next up, we're going to look at the rewards functions and how you would set these up to work with our rewards server. So all rewards functions in Predibase are just standard Python functions that require 3 arguments: the prompt to score, or that was used to generate the completion, and then a dictionary containing that will contain the full example, the full row of data at runtime. And these should each return, any reward function you write should return a single float a value between 0 and 1, where 0 is no reward and 1 is the full reward. So yeah, let's get started looking at our reward functions for this. So the first, like Samir told us, is the correctness function. In this, we're going to check that the model output the correct tool and arguments as an answer. We give it partial credit for choosing the correct tool, or choosing full credit for choosing the no tool if no tool was required, partial credit for recognizing that a tool is required, choosing the correct tool, and giving it the correct arguments. And if it gets all three of those pieces correct, we give it a full 1.0 reward. If you need any external packages, for example, we're using some of the standard library packages here. You just need to import them inside of the function, and you'll have full access to whichever packages you are importing. If you need a package from pip, you can configure the fine-tuning job to recognize that need, and we'll pull it in for you at runtime. And then also, just as an example, you can see how we would get any additional information from the example dict here. So like, we directly want to check against the expected tool call in this reward, and we're provided the tool call through the example dict. And then we just go through and extract the predicted tool call from the completion. Let's go ahead and that. Okay, next up is our formatting reward function. And again, this is just checking that the model is formatting its responses as we directed with the think tags and the tool tags, and that any predicted tool has both a name and an arguments key fields inside of it. We give partial credit for having some of the tags. We give partial credit for only having one of each type of think and tool tag, and then we give the final bit of credit for structuring the predicted tool correctly inside of the tool, the tool tags. And then we're going to add one more reward function here. So this is going to put a limit on the size of our completions. In those agentic systems where there's a lot of communication, you need fast responses to direct to the correct tools. You don't want very wordy models. You don't want models taking too long to output their completions. So we're going to put a hard cap of 2,000 characters on any completion. If the completion is longer than 2,000 characters, then it gets a 0. If it's less than 2,000 characters, it gets a 1. And so with that, we have, just as a reminder, 3 reward functions. We're checking for correctness. Did it solve the problem correctly? Formatting, did it follow our instructions on how to format the response? And length, is the model being concise? And these are going to trade off during training to sort of mold the answer into what we're looking for, mold the completions into what we're looking for. And with that, we're going to set up the Predibase client, upload our data, and kick off a fine-tuning job. So here you'll see we're grabbing the Predibase client from Predibase package. You pass in the API token, which you can get from the settings page in the app. We're going to attempt to upload the data set. Now you'll notice I didn't actually write out a file here. I already have this in, but if you had not written, if you didn't already connect the function calling data to Predibase, this is how you would go about it. You just use our from file to push a local file up to the platform. Finally, we are going to kick off the training job. So first, we're going to get or create an adapter repo, and this is just a way to organize adapters. If you're training multiple on the same or even different data, you can keep track of their performance that changes over time. And we're going to configure the RFT job here. So the first thing you'll see is we have this GRPO config object. This has a number of parameters that are central to running the job, like you specify the base model. So in this case, we're going to be training a Quinn 2.57 billion instruct adapter. then we're going to specify that for each prompt on each epoch, we're going to generate 16 completions. And this can be changed to make training run more quickly or to generate more completions if you want to try to sample a wider variety of completions. Like with other inference or prompting, you can set some sampling parameters like max new tokens to control the max length of your completions, temperature to control the variability of your generated text, top P, top K, a few and other parameters that affect text generation. And lastly, we're going to pass in our reward functions. So we have this reward functions config that you give a human readable name or any name to and pass in the functions. So we're calling them correctness, format, and length, just for so that we can and we'll see in the app that's how they're referenced. We package the functions and ship them to Predibase. We handle all of that for you, so you don't have to do anything special. Just point the reward functions config to the reward functions you want to use. Then we give it our data set, our repo to store the adapter in, and an optional description, and we are off. Yeah, there. So we've started a new job, and now we're going to come over to the app. I kicked off a job about an hour ago to show everyone what a training job would look like in the loop. If you've used Predibase before, this page will look somewhat familiar. Has some details about the adapter, about training here at the top, but then the body here is immediately going to look new. The first thing you'll see is our reward functions tab, where you can view the functions that were submitted to this training job. So you'll see we can flip between our correctness, formatting, length functions here right in the UI. You can use this to spot check for any inconsistencies. You can use this to make sure that if you suspect there's an issue with your function, you can use this as a quick check to just see if anything jumps out at you. And later on, we'll see that you can track, if you update the reward function, you'll be able to see all of the functions you've used right in this viewer. Next up, you'll be able to see reward graphs. So on this tab, you'll have one plot for each reward function. You're seeing here step level metrics. So every time we generate rewards, every step of training, we'll get a value back. These are averaged over the batch for the step. We also keep track of the total reward, which is a sum of our 3 reward functions here. And we keep track of the standard deviation of the rewards, so you can see how stable training is. And generally speaking, you want these to show an upward trend as training goes forward, unless you're getting full rewards. In which case, you might want to reevaluate your reward functions because maybe they're a little too easy for the model. Okay. On the next tab, you can see logs coming from the reward server. So these are pulled directly from the reward server as training is going. There are some sort of standard logs that every training run is going to get, just giving you a progress update, where you are, which epoch you're on, the dynamic timeout for the particular reward function that's being run, and then any print statements that you put into the reward function will also show up here. And that's going to be really helpful for debugging if you are still working on your reward functions. If you just want to see where you're ending up inside of the reward function, say you keep hitting a partial credit, you should be able to see exactly what's happening if you add in some logging. As you train, you can hit refresh here to get the latest logs. Also, if you switch off and back to this tab, it'll refresh as well. It's just a handy way to get some insight into how training is actually running. And the final tab is our completions viewer. So what this is a full list of the prompts and completions that have been generated over the entire course of training. So you'll see in this table, we have, here are the first 10 prompts. They're a little truncated. We have a feature that lets you strip the sort of common parts of the prompt. So if you have prompt template, if you have a system prompt that's common across all prompts, you can hit this, and it will just show you the relevant differentiated portion. For each prompt, you can see that for which epoch we've recorded the latest completions. You can see the average correctness score, format score, length score from the current step that we've recorded for the prompt, as well as the total, and then the additional metadata that the additional columns that you provided with the data set. So here is the tool call that we're looking for this particular prompt. Scrolling down a bit, we've selected prompt 1 here. I'm gonna just switch this to prompt 3. We can see the full prompt right here in this viewer. You can read through, make sure everything is looking good, remind yourself of what this prompt is asking the model to do. And then right below that, you're going to see a side-by-side comparison of a completion, by default, the very first completion for this prompt in the first epoch, and the highest scoring completion from the latest epoch. And so you can kind of use this to keep track of how your model has developed over time, how completions are improving over time. Just flip through the epochs here really quickly and get a nice side-by-side, easy to understand view of how your model is performing. And if you want to see the full list of completions, they are all present down here. If you want to update the viewer, let's say we want to look at these two side by side, you just hit these L and R buttons. It populates up here, and so you have a lot of flexibility for running the comparisons between each completion. And you can also filter by epoch and reward function and value of reward functions. So let's just, there we go. So that's a quick overview of how we some of the observability tools we built to make RFT easy for you. One thing you may have noticed though is that when we're looking at these reward graphs, it looks like the length function we set up, which again was a hard threshold on the number of characters, is always returning 1. The model's always being pretty concise. But maybe a hard threshold was not really the intent of what we were trying to do. We want to encourage the model to be concise, but not pick an arbitrary number of characters as the max. So maybe to give something a little more informative, we want to create a sliding scale that gives a score relative to a max length here. So we're going to set up this updated reward length reward function that gives a reward based on the ratio of generated characters to that threshold that we set up before. And then we're going to update the running RFT job in place. So the first thing we're going to do is grab the path to the adapter, which if you're looking in the UI is this right here, and you can just copy it really easily. And then we're going to get the config for this training job. We're going to update the reward functions in the config. And then we're going to push the updated config to the job. We're going to run this really quick. And we'll see, there we go. Now, if we go back to the reward functions tab, you'll see that we now have two versions of the length function, our original that had the hard limit on completion length, and our more flexible version 2 of the length function. And this will be updated in place. So it would take a second. We may not see it here right away, but as soon as the next step completes, we'll see the length v2 function pop up here. Length v1 will stop populating in this graph, and the average will update to account for both. So that is an overview of RFT in Predibase. And now I am going to hand this off to Jeff Tang to talk to us about managed RFT and the Predibase platform.
All right, thanks, Jeff. As you heard, I am also Jeff. Now that we've taken a look at what the RFT user experience is like on Predibase, I want to take just a couple minutes to spotlight some of the things that are happening behind the scenes. So first, a really quick reminder on how GRPO works, right? So during the training process, the model that's being trained is going to generate sets of candidate outputs, and these outputs will be scored by reward functions, and the scores are fed back into the training loop to update the model weights, and then everything repeats, right? And we've had a great discussion about how writing good reward functions powers the RFT process. And if you're training a model this way, that's what you want to spend your time and energy doing, right? Is focusing on writing good, useful, bug-free reward functions. Unfortunately, we've also seen that GRPO training is kind of complex and interactive, right? You've seen the UI and the tools that Jeff K was just demoing. So before you get to focus on reward functions, you first need to, for example, write or find an open source library that provides a GRPO compatible training loop, right? And you need to evaluate that it works for your use case and your models. Next, you'll need to handle the model serving portion of RFT, right? This is kind of a unique feature of how RFT works. So you'll need to have a server that's going to efficiently load in each new updated intermediate version of your model that you're training, and it's going to use that to generate the outputs that can be scored by the reward functions. Since this is happening many, many times during the training process, the efficiency and speed of generation is going to be a big factor in how long and, by extension, how expensive your training will be. And of course, once the model generates these candidate outputs, they need to be scored by the reward functions you provided. So you'll need scaffolding that connects these three components together into a tightly integrated loop. Assuming you have all of this code, right, all these assets, then you need to get access to the compute on which to run them, right? GPUs are expensive and they're limited supply. So you'll need to consider trade-offs between availability, cost, and power, which can vary widely depending on what compute provider you're using, as well as what model or models that you want to fine-tune. You also want to keep in mind that GRPO training requires GPUs for both the training loop itself and the inference server that's going to be generating those candidate completions for scoring. Once you've acquired compute, then it's time to find the right configuration of parameters that work on your selected GPUs and with your target model and dataset. There have been some questions in the chat already on how you set certain parameters, and these are all things that you're going to have to experiment with and find and figure out what works for you, right? Context window size, model quantization, and a whole bunch of other things are going to be very important for optimizing your training speed, avoiding memory issues, all these things. And you go ahead and rinse and repeat now for each new model architecture and size that you want to use. And as we've seen, RFT and GRPO are highly interactive processes. So as training progresses, it's very important that you have access to real-time metrics and logs, like we showed in the example, to quickly identify training plateaus, reward hacking, or any bugs that are in your reward function code. So you have to decide how you're going to store and stream and visualize these key metrics. And finally, to evaluate and update your reward functions, you have to build interfaces and tools that allow you to understand what the model is and isn't learning from your existing reward functions. For example, the UI that Jeff K was just showing that allows you to see what the prompts are, what the completions are, and how those have changed over time. Once you understand what your model is doing well and what it's not doing well, you want to be able to iteratively modify your reward functions to guide training and guide learning in the correct direction without having to restart your training from scratch every single time, right? So that's quite a lot to think about. But the good news is these are all things that you don't have to think about on a managed RFT solution like Predibase, because we are already built on top of state-of-the-art training and serving stacks, including our popular Lorax framework for serving multiple adapters on a single machine, which is exactly what this reinforcement fine-tuning process wants to do. We can provide exactly the type of tightly integrated experience that's needed for GRPO training. So in this diagram here, you kind of see how the flow is going, right? You have your base model, you have your trainable adapter on top of it, using parameter-efficient fine-tuning. And as each new version of this LoRa adapter is created during training, it can be loaded into Lorax. Lorax allows you to quickly and efficiently generate your completions from this new version. Those are fed into the reward server, which scores them, sending those scores back to the trainer, and the loop repeats. So the fact that we have this tightly integrated infrastructure means that when you're fine-tuning a model, you don't have to spend time setting it up, right? You don't have to manage compute. You don't have to worry about orchestration logic between the many components involved. You don't have to worry about the complexities of the training loop in general. You get a just works experience out of the box, right? As you saw in this notebook, if you can write Python, you can use RFT on Predibase. And of course, you get all the tools you need to quickly and easily iterate on what actually matters to you, which is model performance. Finally, many of you here today are engineers and data scientists and ML practitioners, but I think many of you are also business and enterprise leaders looking to make RFT work for your organization. That means you care not only about the in-the-trenches experience of model training, but also how your organization can adopt RFT in a way that shortens time to value, works with your existing infrastructure, and allows you to control costs and security requirements. These things are also part of the value that Predibase provides. We simplify the AI lifecycle with our world's first end-to-end RFT training platform. So there's no need to cobble together a bunch of open source libraries or build bespoke pipelines that your team then has to maintain. We're enterprise ready by default. We are SOC 2 certified, and we provide either managed infrastructure on demand or deployment into your VPC for customers that are more sensitive to those security requirements. And finally, we intelligently manage compute resources to reduce cost. And because our platform is battle tested and production grade, your team gets to spend its time working on delivering value instead of the everything else, bug fixes, infrastructure scaling, that gets in the way of actual AI engineering. So with that, I'll say that if you're interested in RFT, please come try it out on Predibase today. Or if you have questions and you'd like to dig deeper into your use case, get in touch with us for a more personalized demo. So thanks to everybody for coming today. And now I want to make sure we have some time left for a live Q&A. So I'll hand it back over to Will.
Awesome. Thank you, everyone, for walking through those slides. That was really, really incredible content. So we're going to try to get through a few quick questions. If we don't get to your question, please feel free to shoot me an email. I'm putting my email address in chat right now. It's just will@predibase.com. Feel free to reach out and we'll try to answer it afterwards. Dev, this might be a good one that you can answer quickly. How do you handle situations when computing rewards requires access to internal enterprise knowledge?
Yeah, it's a great question. We spend a lot of time allowing organizations to be able to actually make reward functions that can call out to external services as well, and do that in a secure way. And so if you have access to internal data that can be exposed as a function, you can actually call that function inside of your RFT reward function as well.
Awesome, thank you. And a quick reminder, this recording will be put on YouTube and we'll be sharing the slides out also. Another good question, maybe Dev, if you want, is once you've created a lot of LoRa adapters for specialized skills and tools, is there a framework for LoRa routing so a model picks the best LoRa for the task at hand?
Yeah, it's a great question. I think there's two things here. The first is, how do you serve all of these different LoRa's that exist efficiently and be able to version them? And then the second is, how do you just select the one LoRa that you want to be able to use? First thing I'll mention is Lorax is an open source multi-LoRa inference server, allows you to host all of the different LoRa's or the adapters that you have on a task on a single model and GPU. And instead of Predibase, all of these are versioned by default. So every LoRa gets a version. You can actually call, every single one without having to worry at all about the hot swapping or the loading and loading off, just dynamically inside the platform. In terms of like routing between them, what we've seen a customer or two do is actually just build a very simple classifier that serves as the very first LoRa that helps understand which adapter it wants to be able to call to next. Something we're interested in investing in more ourselves as well. And right now, I think it's very easy to just fine tune a model to be able to do that LoRa selection.
Awesome. Thanks, Dev. Another question. This one is about, can you kind of talk about the differences between RFT and within that maybe GRPO and DPO fine-tuning, direct preference optimization?
Yeah. Jeff or Samir, either of you want to jump in for this one?
Yeah, I can take it. I think what you'll find with DPO is it was mostly created with a preference modeling situation. And I think the biggest difference is that like DPO, you basically are training your model to pick between responses A and B, one good, one bad. And DPO, like the main constraint is not online in any way. Like you kind of have to do these cycles where you collect a bunch of preference data, train your model on them. But then for your model to improve, you have to do rounds and rounds of this. I think with algorithms like GRPO or PPO, the core idea is that it's an online learning algorithm and it tends to get much better performance out of the box and is just generally applicable to way more scenarios.
Awesome. Thanks, Samir. Try to squeeze in one or two more. Are we able to measure if the model is affected by any kind of catastrophic forgetting?
Yeah, it's a great question. And Jeff Kinston, I saw that you went off mute, so maybe I'll let you jump in.
Yeah, so I think the easiest way to do that would be following the reward graphs, right? So you can watch the rewards. If you're seeing catastrophic forgetting, you may see one of the rewards take a sharp dive if it's related to what has been forgotten. And in that case, you can go in and update the reward function if you have some idea of what the model is getting wrong. In that case, the completions viewer is also going to help you. So you can look at, okay, at epoch 5, my reward was looking good, but then at epoch 12, it was not anymore. What is the difference between the completions at these 2 points? And so between those two tools, I think you'll be able to both track and address, identify and address the any type of forgetting during training.
Yeah, I'll like quickly add that I think one of the observations from folks in industry is while SFT might be more prone towards or fitting in catastrophic forgetting, RFT generalizes a little bit better and is less prone to aspects like catastrophic forgetting.
Awesome. Well, we are at time. Again, I put the link in for the demo. If anyone wants a personalized demo about RFT, if you have a use case in mind, we're happy to have our team set up time with you. And I also put in my email address, will@predibase.com, in case you want to follow up with any direct questions. We will have the recording up on our YouTube channel sometime this afternoon, Pacific time, so hopefully in the next few hours. And we'll have the slides there also. So thank you all so much for joining. We really appreciate you carving out the time wherever you are in the world. And stay tuned for these materials afterwards and hope to see you at the next webinar. Thanks to our panelists. Have a good day, everybody.